Hi, this is Raghav from IIDST, and today we'll be discussing about big data, Hadoop, Hdfs and Mapreduce. We'll be discussing about what big data is, understanding how it all works, what Hadoop is, how we can use it to process big data, exploring its key components and uncovering the potential of this powerful framework. Firstly, let us understand what big data is. Big data refers to extremely large and complex data sets that traditional data processing applications cannot manage effectively. This term encompasses a vast array of information generated from various sources, including social media, IoT devices, transaction logs, and more. The data can be structured, semi structured, or unstructured and is characterized by five V's mainly. We were discussing about four V's here. The four V's are volume, variety, velocity, and veracity. The characteristics of big data are volume, of course. Big data encompasses massive amounts of data, often measured in terabytes, petabytes, or even exabytes. While there is no strict threshold for what constitutes big data, systems handling large data sets often deal with volumes that exceed the capacity of conventional databases. Hence, Hadoop comes in. We'll be discussing about that later. Big data encompasses massive amounts of data, often exceeding the capacity of traditional data storage and processing system. This volume can be from various sources such as social media, web traffic, sensor data, and financial transactions. Variety. This characteristic highlights the diverse type of data that can be included in big data sets. It encompasses structured data like databases, unstructured data such as text documents or multimedia, and semi-structured data like JSON or XML files, which require different processing techniques. This variety poses challenges in managing, analyzing, and deriving insights from the data. Next up comes velocity. The speed at which data is generated and processed is often critical in big data environments. Many applications require real time or near real time processing to derive insights quickly enough to inform decision making. The velocity of data flow, as we can see here, the velocity of data flow necessitates real time processing and analysis capabilities to keep pace with the ever increasing data streams. Next up comes veracity. Big data can be noisy, inconsistent, and incomplete. The veracity of data is crucial for drawing accurate insights and ensuring the reliability of analysis results. Ensuring data quality is essential for meaningful conclusions. We essentially got to know and discuss what big data is. Summing it up very briefly, big data simply refers to large amount of data that can be used for purposes such as building AI models or for large scale corporations which store their data apart from conventional databases. Next up, we'll get to understand what Hadoop really means. Hadoop is an open source framework designed for distributed storage and processing of massive data sets. It was initially developed by Yahoo and is now maintained by Apache Software Foundation. So what really happens is conventional technologies and conventional databases cannot actually handle such large data sets which exceed terabytes, petabytes, or even exabytes. These are tens of thousands of terabytes of data, and conventional databases and processing techniques often fail at that. So, keeping the future in mind, Yahoo developed Hadoop, which is an open source framework designed for distributed storage. What it does is, instead of keeping all of your data in one place, like a conventional database would, it distributes them across various clusters so that it is easier to get access to a lot of data. It's open source, of course, so everybody can contribute to it everywhere, but we know what's going on behind the scenes, and the code is similar and easy to understand. Scalability. Hadoop's distributed architecture enables horizontal scaling, allowing it to handle datasets of any size. It can distribute tasks across multiple nodes, maximizing efficiency and throughput. So what this means is that Hadoop has horizontal scaling. There are essentially two types of scaling: horizontal and vertical scaling. So in vertical scaling, what we have, vertical scaling basically means to scale up, and horizontal scaling means to scale in a horizontal direction. Let me tell you what these two types of scalings are. So let's say you have a certain PC or a laptop or a device. Vertical scaling means that you add more extra physical hardware to that device to make it more powerful. So let's say instead of 8 GB of RAM, you can have 16 GB of RAM. For let's say 256 GB of storage, you can have 512 GB of storage. You could have a better processor, and that is simply making the one device much more powerful. That is vertical scaling. Horizontal scaling means adding more devices instead of just upgrading the one device, adding more devices that work in parallel so that the work is divided and it gets done more efficiently. So Hadoop has a distributed architecture, which means that it has horizontal scaling, meaning you can add multiple nodes, you can add multiple clusters, Hadoop clusters, so that you can work more efficiently. Fault tolerance. Hadoop is highly fault tolerant, ensuring data integrity and continuous operations even in case of hardware failures. Data is replicated across multiple nodes, providing redundancy and minimizing downtime. Hadoop essentially makes a copy of the data that we store, and it keeps them across multiple nodes. So in case even if one single node goes down, in case we have a failure in one node, we know, we have full confidence that the data is replicated somewhere, we know that the data is not lost forever. So it has high fault tolerance. The replication is determined by a replication factor. Now we come to the last factor, which is cost effective. Hadoop is a cost effective solution for big data processing, as it utilizes commodity hardware, reducing the need for expensive specialized systems. What we mean by commodity hardware is hardware, essentially what it means is that hardware which is not expensive, hardware which is daily commodity. We can use everyday hardware to utilize Hadoop. So it reduces the need for expensive specialized system, which would ideally, what everybody would think while handling big data is, we would need very expensive systems. No, Hadoop reduces the need for that. It uses commodity hardware. So Hadoop, we learned that it's open source, it's scalable, it's fault tolerant, and it's cost effective. All of these which make Hadoop a very good and go-to tool for big data utilization purposes. Moving on to the next slide, we have components of Hadoop. These are very important, as if we understand what the concept of what the components of Hadoop are, we will get to know how Hadoop work, how it all comes together to give us the best output, the best throughput, and the best performance possible. One of the most important parts of a big data, let's say a big data software such as Hadoop, would be the storage, of course, because we are handling big data. Data needs to be stored. Comes in HDFS. Hadoop Distributed File System is the storage component of Hadoop, providing a distributed and fault tolerance file system for storing massive datasets across multiple nodes. So this is where your data will be stored, inside nodes and clusters inside a HDFS or Hadoop Distributed File System. It's distributed, it's fault tolerant, it is everything that we discussed in the previous slide. Hadoop HDFS is where your actual data gets stored. Yarn. Yarn is a yet another resource negotiator. It's Hadoop's resource management component. It allocates resources to different applications running on the Hadoop cluster. So think of it like the let's say it's like the task manager. It's like the CPU of your Hadoop software. It thinks, it analyzes, it allocates resources to different application. It manages every resource that Hadoop has: storage, memory, CPU, network, etc. It manages everything and allocates it to what component, what software, what part of Hadoop needs it the most. It depends on different applications and depends on what the need and requirement is. That is what Yarn does. Yarn thinks and allocates resources accordingly. Mapreduce is the core processing framework of Hadoop. This is right here the processor of Hadoop. It provides a programming model for processing large datasets in a parallel and distributed manner. So we essentially say it's a MapReduce job, because MapReduce takes in the data, it processes it in such a way that it can be easily stored on Hadoop nodes and Hadoop clusters. So HDFS is where the data is stored. Yarn manages all the resources, allocates the resources accordingly. And MapReduce is the core processing framework which processes the data and then stores it in HDFS. Now, apart from this, you can add on other applications to these three were the core Hadoop. These are the core functionalities of Hadoop. Apart from that, you can have other applications. You can add frameworks on top of its core components such as Hive, Pig, and Spark. Hive is data warehousing, Pig is a data flow language, and Spark is in memory processing. All of these can be added on to Hadoop to make the job much more easier and for other purposes as well. So these were the key components of Hadoop. Moving on, let's discuss a bit about HDFS or Hadoop Distributed File System. Now HDFS is where, as we discussed, is the place where all of our data is stored. So it has three major components. the name node, the data nodes, and the block storage. The name node is the central master node responsible for managing the file system namespace, maintaining metadata information about files and blocks. And the data nodes are the worker node that store actual data blocks. They communicate the name node to retrieve metadata and store data blocks as instructed. So HDFS works in a master slave architecture where name node is the master and data nodes are the slaves. So what happens is that name node knows about the details of every file and block on the Hadoop cluster, and it knows where the data nodes are, and it essentially gives order to the data nodes to store this information in this place, and the data nodes abide by that order and they do as they are told by the name node. The name node contains all the metadata meaning information, crucial information about the data nodes. It knows where the data nodes are, it knows what data is present on the data nodes, and it gives commands to the data nodes to store them as per needed. Data nodes are the work nodes that store actual data blocks. Of course, they do what is told to them by the name nodes. Next up comes block storage. Data is split into blocks and is replicated across multiple data nodes for fault tolerance. This ensures data availability even if some nodes fail. Block storage is essentially the place where data is stored. These name node and data nodes come under block storage. It's split into blocks and replicated across multiple data nodes for fault tolerance. This ensures data availability if some nodes fail. That is, we have discussed this already. Data locality. HDFS aims to keep data close to the processing nodes to minimize data transfer time and improve performance. Now, this is done to reduce processing time, because see, the closer we are to the source, the lesser time it will take for communication and messages to go through each other, right? So the closer we are to the source, the better it is for processing and for the time taken, of course, to do stuff. That is why it keeps the data close to the processing nodes. That is why the data will be closer to the name node or the Mapreduce, the places where the Mapreduce tasks are happening. Let us discuss about Mapreduce now. Mapreduce is Hadoop's data processing framework. It is used to process the data that is eventually fed into the system. So it has three phases: the map phase, the shuffle phase, and the reduce phase. The map phase processes each input record individually, transforming it into key value pairs. This phase is parallelized across multiple nodes, enabling efficient processing of large data sets. And then comes the shuffle phase. The shuffle phase, I'll just talk you through it, and then I'll explain it once I get it all done. The shuffle phase gathers all key value pairs with the same key, grouping them together for further processing. This is done by transferring data between nodes to group related data. Then comes the final phase, which is the reduce phase. It iterates through each key and its associated value pairs, applying a user defined reduce function to aggregate or transform the data based on the specific task at hand. This phase is also parallelized, allowing for efficient processing of large amounts of data. Now, what these three phases do is very simple. Firstly, the map phase will split all the data that you have into key value pairs. After that, the shuffle phase will shuffle through all the key value pairs and then combine all of similar data sets. It will combine all of it and then aggregate the data and transform the data. That is the reduce phase, and then it will all come together and be stored on the HDFS block. So the map phase splits the data. The shuffle phase shuffles the data, grouping them together with the same key. And then the reduce phase will aggregate the data and combine it all together and then store it in the node. As you can see, it will gather all the key value pairs with the same key, grouping them together for further processing. This is done by transferring data between nodes to group related data. We have to group related data together so that it's much easier to fetch once we want it to. Now moving on, we come to the use cases and applications of Hadoop. Hadoop is used in social media, e-commerce, finance, and healthcare. It's used for analyzing user trends, recommendations, and sentiment analysis in social media. It's used in the backend for customer behavior analysis, fraud detection, personalized recommendations. Finance, it's used for risk assessment, fraud detection, and real-time market analysis. In the healthcare segment, it's used for medical research, genomics research, and patient data management. All four of these have millions, if not billions, of consumers across the world. And hence, they obviously carry with them a lot of data, that is big data. Hence, Hadoop comes in handy while running certain algorithms on these data. We can utilize Hadoop for full efficiency. Some challenges and limitations of Hadoop. complexity, performance, scalability, and security. Hadoop requires expertise to set up, manage, and optimize, making it challenging for organizations with limited resources. Performance. While Hadoop excels in handling massive datasets, it can be slower for real-time processing compared to other frameworks like Spark. So if you can see right here, it says that Spark is faster than Hadoop, but we learned earlier that we can combine Hadoop with Spark for better performance. So yeah, scalability. Scaling Hadoop clusters beyond a certain point can be complex and require careful planning and resource management. Security. Ensuring data security in a distributed environment like Hadoop requires robust security measures and careful access control. So these were the challenges and limitations of Hadoop. Future trends and innovation in big data and Hadoop. The future of big data and Hadoop is marked by exciting advancements in technologies like cloud computing, artificial intelligence, and machine learning. These innovations are transforming how we process, analyze, and derive insights from massive data sets. Expect to see advancements in real time analytics, data visualization, and the development of more sophisticated data processing frameworks. With the advent of AI and chatbots such as ChatGPT, Perplexity, and Claude, we are now using big data more than ever before. That is why Hadoop is a very future-proof technology because it comes in handy and it will be coming in handy during a lot of algorithm building and a lot of model building in the coming years. That is why Hadoop is something that we should all learn. That is why Hadoop is something that we should all learn and prepare ourselves for the future. That was it for today, guys. This is the end of the slideshow. Thank you for your time and happy learning.